Assalamualaikum warahmatullahi wabarakatuh. Today, I would like to say thank you very much for this time for presenting my research on international research collaboration. So, I would like to say thank you to our reviewer of LP2M, and please let me to share screen my research slide. So, so the title of our research topic is seismic microresonation and seismic intensity for West Pasaman based on microtremor result. I am the head of this research. Name is Rusnadi Rahman Putra. And then we have two members, research members. One is Toto Andayono and second one Petra Rihwan. Today, I would like to present our background. The background, when we see this figure 1, we can see clearly most of the earthquake occur in shallow depth, where the depth is from 3 kilometer to 100 kilometer. And then when we see in these figures, the Indonesia region is uh, surrounding of Indonesia region, earthquake occur in shallow depth. And then when we see the background, seismicity in Sumatra from 79, 2022, the earthquake greater than 4 in moment magnitude. So clearly in Sumatra Island and West Sumatra, and then some earthquake occur at least uh, at least 10 years before until now. So the latest one, the earthquake is Kajai earthquake, occur in February 25th, 2002 with magnitude 6.1. And then this is the effect of the earthquake. The effect of the earthquake affected damage to construction. Heavy damage is 1,200 houses and 55 school buildings. This is a heavy damage. And the moderate damage is 1,000 egg houses, and then slight damage greater than 2,000 houses. And then the earthquake affect to building, affect to infrastructure around Kajai, and then some houses damage in Simpang Empat. And then when we see the seismic intensity, the earthquake intensity is in located is red one is from 6 to 7 in MMI, Mercalli modified intensity. And then research proposed one is seismic coordination based on microtremor single observation. And second is seismic intensity in Japan meteorology. And the third, liquefaction potential based on microtremor single observation. This is the this is the device we use for a field observation. We conducted the research field survey from 27 to 30 February 2002. So that one is the first field survey just one day after the earthquake occurred in February. And then the second one in July, from 3 to 2020. The device that we use is GPL 6A3P with 3-direction sensor. Duration is 10 minutes, sampling frequency to 100 Hz. And then we use this equation to determine subsoil structure, period, and frequency. So we call that H vertical spectral ratio, X mean horizontal vertical spectral ratio, and then we use the equation to calculate the frequency and period. This is the observation site distribution wall Pasaman, West Pasaman, and the red one, the circle red is Kajai, And then the yellow one is distributed point where we installed the device. The installed device takes 10 minutes for every site. And then this is the result of seismic coordination for West Pasaman based on the natural period. As we know, where the site has the high permanent period, it means the soil characteristic is soft, and then is can create amplification, amplification due to the earthquake occur in the seismic bedrock. And then this is a Kajai where the earthquake occurred before, and then some places surrounding Kajai affected the earthquake. So this is very important to mitigate the future earthquake for people who are living here and also to the person, a stakeholder in West Pasaman. And then this is, we also calculate seismic vulnerability index, so we can predict future damage when the earthquake occur anywhere in West Pasaman. And also the earthquake occur in the fault line near West Pasaman. So we use this equation, kg equal, kg is amplitude of microtremor that we obtain from the microtremor observation divided frequency, site frequency. And then we also calculate the liquefaction potential in West Pasaman, where we know the liquefaction potential is amplitude quadrant 2 divided frequency greater than 5. And then from this figure, we can see most of the area in West Pasaman has high potential liquefaction occur in the future. And then we also calculate the ground shear strain. And as we know, the ground shear strain very important for us to know, because from here we know the dynamic property of the subsurface soil we can determine, because this is related to future vulnerability. So when the ground shear strain higher in that location, so it means there is possibility the vulnerability of liquefaction potential will occur in that site. So we can see this table. So when the size of strain gamma 10 minus 1, so the phenomena can occur in the future landslide liquefaction, and then dynamic properties is collapse. So this a worry about that. And then we also calculate the ground shear strain. So we can see the the ground shear strain map with ground motion is the predicted earthquake ground motion. So the input is the predicted earthquake ground motion. We can see clearly the potential future vulnerability will occur in here with a high possibility. And then we calculate the seismic intensity. We use GMA intensity. And then the step by step, we use several steps. We use a question 1, and from question 1 to question 4. And then we calculate, this is distribution of questionnaires distribution. And then we calculate the seismic intensity. And then this is the seismic intensity distribution, the figure 10. So we can see the area with higher number of seismic intensity. It means the area is related to high ground shaking currently and in the future. You can see in Talamau. So Talamau is 6 plus, and then Pasaman, and the short side is 5 minus. So when we correlated it to MMI, 6 plus is is equal with 9 or 10 in MMI. So 9 and 10 is high ground shaking and then give bad effect to the building. And then the result of the reset one is the surface of ground characteristic is rock located in earthquake, but the seismic intensity and vulnerability index are high. And then second one, the seismic intensity has high relationship with seismic vulnerability index. And then this result, we already wrote article, but the article still draft, and then we would like to submit this paper to our destination paper in Civil Engineering and Architecture Journal or related journal. Thank you very much for your attention, and we hope this research continued for next year. And I would like to say thank you to reviewer who are reviewing my uh, uh, this report. Thank you very much.